everyone, my name is Angel Igareta and today I'm going to tell you about deepfakes. What are they? How are they being used nowadays? And how can we detect them? So first of all, what are deepfakes? Deepfakes are deep learning techniques that are used to create synthetic media such as video, images or audio. Very convincing. For example, one of the most common ones is the one that you're watching right now. It's called face swapping and is the act of swapping my face with other one else. For example, celebrities or politicians such as Donald Trump or Greta Thunberg. Despite of what you have just seen now, it's a pretty cool application. These deepfakes techniques can be applied for creating fake news, financial fraud, revenge porn, or celebrity pornographic videos, and that can cause threats in political, safety and security aspects. The first deepfake video was created in 2017, where a face of a celebrity was swapped into a porn actress and published it in Reddit, so that causes a lot of alert. And in 2018, Reddit banned all this kind of content, classified as fake porn, and Twitter, GIFCAT, and in the end Pornhub and this type of content. On top of that, these videos can be used to threaten national security. For instance, imagine creating a video of the President of the United States saying dangerous military actions, and that could influence the national state. Despite all these dark and negative applications that we have seen, there are many positive ones, like for example creating voice for people that have lost theirs, or creating a movie where the actor can have different ages through deepfake algorithms, such as the last movie about the Irishman in Netflix that used a lot of aging deepfakes. Okay, so how are these deepfakes being generated? How can we generate them? So I'm going to explain here in this video the basic idea. However, in the last years it has been improved a lot with advanced techniques, but I want to only focus in the basic idea because it's very simple to understand. The generation is basically centered in a auto-encoder encoding and decoding structure. An unsupervised artificial neural network that learns first how to efficiently compress data down to a selected size, the encode step, and then reconstruct the data from the compressed representation to one that is as close as the input as possible, the decode step. In order to measure how well the decoder is performing, there is a reconstruction loss, and this is the difference between the original image and the output one. As the goal for this application is to swap two faces, we will need two autoencoder-decoder structure. The first one will learn the facial expression for the subject A and reconstruct the face into, again, the subject A, and the second one will perform likewise with the subject B. Then, as you can imagine, what we can do to exchange those faces is first of all have the same encoder in both autoencoder-decoder structure, and by sharing those net in the encoding structure, we can simply swap the decoder, and then it will allow us to deconstruct those facial expressions in subject B. Hence, swapping the face of subject A into subject B. A major improvement in the area was the introduction of generative adversarial networks. These are algorithm structure composed by two neural networks. The first one called generator and the discriminator. The generator starts producing data, and the discriminator tries to differentiate if they are real or fake. However, that training data of, for example, faces, that is our section, is only seen by the discriminator. The generator will never see that input data and will try to produce images that are similar to the faces that it has the input data. But how if it doesn't look at them? There is a discriminator loss that is received by the generator, and hence in each epoch it can improve the data generation until there is a point where the discriminator can differentiate if the image received is real or fake. With the addition of GANs, we can produce great results. However, there is a major problem, and is that we require a lot of input data for generating a very good deepfakes. So that's why there is a technique being more popular nowadays that is called few-shot learning. One of the latest papers applying few-shot adversarial learning in deepfakes developed a system that can generate frame few and one-shot neural talking head models of previously unseen people. On top of that, there is other that I'm showing right now, and the most interesting thing about this one is that it's not only able to animate faces but any specific object like faces, human bodies or cartoons where the system have already been trained with a set of videos of that object. With all these advances in the area of deepfakes that can cause national threats and privacy or security issues, there have been a lot of research about deepfake detection, and basically the goal of deepfake detection is a classification problem to distinguish between tampered or real images. In deepfake detection, two major categories can be distinguished, and those are first, fake image detection and fake video detection. In fake image detection, one of the most dangerous techniques is face swapping, because cyber attackers can use it to penetrate the authentication system and to gain illegitimate access. Recent research funded by Google and DARPA, the research wing of the Pentagon, published a technique that is able to spot with much better performance than previous models celebrity or world leaders deepfakes. The method uses machine learning to analyze a specific individual's style of speech and movement, what researchers refer as a soft biometric signature. Nowadays, there are multiple deepfake generation programs that can be used with no additional experience and that are open source, so you can just see them in GitHub or in the internet. I'm going to present some of them, but with the aid of educational purposes and to help detecting these deepfakes and aware people about the real threat that they are causing. For instance, there is Deepfakes Lab that I think is the most popular one. It's the leading software for generating deepfakes, and it contains very advanced techniques, so you will need a bit of time to get it to know better and generate real deepfakes. Then, for example, there is Faceswap, the one of the first application, and that has been improved over the years to recognize and swap faces in picture and videos. For instance, there are two very good ones that I like. The first one is the first order motion model for image animation. It allows us to apply the animation of a driving video to a unique source image. And there is included a demo in Google Colab, as you can see, for example, now, me talking like that. And for instance, if we saw the video, you can see a famous celebrity talking as if it was me. And this result is achieved only with a picture of a target celebrity, so it's pretty convincing for only one picture. As a conclusion, I want to say that from my point of view, it's a very complicated situation happening with deepfakes, because when there is a new technique to generate them, well, there is the academic research about how to detect them, and most of the developers are trying to detect them, and then the hackers will try to bypass those detection techniques to generate better models. So it's like a antivirus situation where there is no winner, and this will always keep evolving. And I don't think there is a solution for this problem, but to aware people about the threats, about not to trust everything we see on the internet, and about what's very careful, what we share the data and where do we share it, and if we share a lot of pictures of ourselves, see what we are exposing ourselves to. So this is all I wanted to say. Thank you very much for seeing this video, and see you next time. Bye!